Okay, today I'm going to talk about Newton's first law. So Isaac Newton was a physicist, and in the 1660s he worked out these laws of motion, and today we're going to learn about Newton's first law. So essentially, summed up, the first law states that a resultant force is needed to make something start moving, speed up, slow down, stop moving, or change direction. So we're going to take these one at a time and see what they actually mean. So let's start off with start moving. So let's imagine right here I have got a very badly drawn van. So here's my van, like this. Okay. So at the moment there is no resultant force. There's no overall force. The weight of the van going that way and the reaction force are balanced, and there's no forces acting in either direction here. So at the moment, the object is stationary. So when the driver gets in the car and they start the engine, we are going to have a resultant force. Now, all a resultant force means is an overall force. So if these arrows are different sizes, then we are going to have acceleration in a particular direction, or deceleration, getting slower. So if, as soon as this person gets in the car and starts here, puts their foot on the accelerator, we're going to start moving. So there's the first way that that resultant force can happen. So we also can speed up. That's our second scenario. So let's imagine right here, we've got a different van. Now this van, at the moment, when we start looking at it, it's travelling at a constant speed. I can tell that it's travelling at a constant speed, or constant velocity, if you will, because these arrows are the same size. So it means the forces are balanced. So at this stage, when the forces are balanced, it's going to carry on travelling with the same velocity. Now, if I want to speed up, this person's going to put their foot on the accelerator, and it would cause the force to become unbalanced. This will create a non-zero resultant force. That means a resultant force which has a value. As a result, this car here will speed up. So what's happening if a car is to slow down? So again, let's go back to the example of a van. Again, let's imagine at the beginning of this situation, the van here is travelling at a constant speed. So those arrows are the same size. At the moment, we do not have a resultant force because the forces are balanced. Now this person might see someone crossing the road. They might need to slam on their brakes. So it's going to increase the friction between the wheels and the road. Therefore, we are going to have an unbalanced force, creating a resultant force that way. So as a result, because there's an unbalanced force, we're going to have deceleration, or slowing down. So it slows down. Okay, so we just need to kind of carry on that idea a little bit to think about stop moving, because essentially, if we continue to apply that brake to this car, we continue to brake, eventually this will come to a stop. So that there is also stop moving. So again, because we've got unbalanced forces, we have a non-zero resultant force. That means an overall force that's acting in that direction. So this moving object will come slower and slower. The velocity will get lower and lower until it's stationary. Stationary means not moving. Now the final one to look at is change direction. So let's imagine now, again, this van here is driving along the road. Let's say it's travelling at a constant speed. I can tell it's travelling at a constant speed because these arrows are the same size. So at the moment there's no resultant force. Then all of a sudden, another vehicle comes absolutely crashing into the side of this van. Let's say it's going to cross a red light. This other vehicle comes smashing into the side. Now, because of the force applied here, we're going to have an overall force, which is a resultant force acting in that direction because the forces will be unbalanced. So we've actually allowed this vehicle to change direction. So that is the final way that a resultant force can affect motion. So just to summarise, a resultant force is an overall force when the forces are unbalanced, and there are 5 different ways that moving objects can be affected, and all of the diagrams are there. Thank you.